tetrahedral bonds between the nearest atoms or nearest neighbor atoms. So this is the nearest neighbor atom and this is the nearest neighbor atom. So the rod here represents the tetrahedral bonds, and the small dashed lines delineates a tetrahedron as particle shown in the figure. Since the alkali halide and the alkaline earth chalcogenide compounds fit the ionic module so well, and it is significant that neither module or neither model fits the structures of the semiconductor compounds. The extent to which the semiconductor crystals exhibit ionic or covalent bonding is not clear from crystallographic data. So let us describe the wave function by writing as psi is equal to, it is A covalent, psi covalent plus A ionic plus psi ionic. Therefore, the coefficients of covalent and ionic wave functions here are normalized. So when in this equation, the covalent wave function and the covalent wave function and the ionic wave function are normalized. When these wave functions are normalized, you get a structure like this. And what are lattice vibrations? We have discussed atoms in a crystal as residing at particular lattice sites. Let us say some atoms in a crystal are residing at a particular lattice size. But in reality, what will happen is they undergo a continuous fluctuations in the neighborhood, and therefore the regular positions of the lattice will be disturbed. And because of this fluctuation or these fluctuation arise from the heat or thermal energy in the lattice. When you supply thermal energy or when you dismantle the lattice, what will happen? The fluctuation arise from the heat and become more pronounced at higher temperatures. Since the atoms are bound together by chemical bonds, the movement of one atom about its site causes the neighboring atoms to respond to this motion. Therefore, what will happen? The chemical bond acts like spring that stretch forth and compress repeatedly during oscillatory motion. So, in the oscillatory motion, what will happen? This atom acts like springs. So, the chemical bonds that act like springs that stretch and compress repeatedly during oscillatory motion. So, due to this, what will happen? Many atoms will vibrate, and this vibration spread throughout the crystal. And due to this, every type of lattice has its own characteristic frequencies of vibration called normal modes. And the overall collective vibration motion of the lattice